And then we'll have reaction. I said it before, and this is new for us, store Ec. So this specifies the stoichiometric coefficients for all reactants in each chemical reaction as a line of numbers. So we'll have 3 reactions, and these are the stoichiometric coefficients for all the reactants. And so we will set the hydrocarbon first. So that's why we will have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. First 9 of the hydrocarbon components, and then continued with the 4 water components. So 0, it means that they will not be involved in the reaction, and 1 or any positive number, they will be involved in the reaction for the 3 sets of reaction. And stop rod, this to specifies the stoichiometric coefficient for all components. I mean all products in each chemical reaction. So for example, this will be, water will be consumed in the reaction, ester aqueous will be consumed in the first production, but we will produce alcohol and acetic acid from the first reaction. And then here ester will be consumed and ester aqueous will be produced. This one, ester aqueous, will be consumed, ester, hydrocarbon ester will be produced. And then this is the reaction rate. I mean rate constant of the chemical reaction. We have, 3 reactions. So the fastest reaction will be at the reaction 3. And then this react fast. So this is to specify the component phase in chemical reaction. So you see we have water phase and ester, all phases. Okay. And react act, this is to set the activation energy for chemical reaction in metric unit, kilojoule per kilogram mole or kilojoule per kilomole. The activation energy is constant for each reaction. So here we set activation energy to be 0. It means that the reaction will just happen, automatically, naturally. So you don't need to provide any, additional energy like heating, something like that, higher temperature to activate the reaction. Okay, the reaction is spontaneous. It will just occur. You don't need to provide any energy to activate the reaction. So that's the activation energy. You need to provide that amount of activation energy to activate the reaction to happen. Okay. And then react chord, this is orders of chemical reaction with respect to the component. This parameter can possess different values for the same component at different reactions. Okay, and then others. Okay. And then this is the reservoir temperature, density. Okay, and then raw compressibility as usual. Okay, so far so good. And then, yeah, maybe we can start to run. And sorry, this one will be better. Okay, and then let's see the water and then molar density of the alcohol.